Okay, hello students. Today we're going over the 2.1 extension notes. They're fairly short, so hopefully we can get through them pretty quickly. The difference between a discrete function and a continuous function is what we're going to look at first. A discrete function means they're separate points. So it's a set of points on a graph, like this. Okay, they're all separate. Continuous function is an unbroken line or curve. So it's where all the points are connected, like this. So we're going to use this knowledge to decide if functions we're graphing are discrete or continuous in this section. So for the first example, we have y equals negative x plus 3 for x is greater than negative 1. They want us to classify the function as discrete or continuous and then identify the range. Remember, range is the y values. Okay, so first of all, for graphing y equals negative x plus 3, it has to be greater than or equal to negative 1. So our first point is going to start where x is negative 1. So in order to figure out what that point is, I'm going to replace x with a negative 1. This becomes a positive 1 plus 3, which means my y value is 4. So for our starting point, we have negative 1, 4. Every point from there has to have an x value greater than negative 1. We are using the slope to plot the rest of them, and our slope is that negative sign, so it's a negative 1. So from this point, I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And you continue that pattern. Draw a line with arrows. Notice, since all the values are greater than or equal to negative 1, that means it can be any point from negative 1 on, including the decimals. So that's why I connected all these, because it could be any of those points. That means that this is a continuous function. For the range, we're going to look at our y values. Well, at our starting point, the y value was 4. And notice how the line is going down. So those points, the y values for these points are getting smaller and smaller. That means for our range, y is less than or equal to 4. And we're going to write this in function notation, which means we're going to write y such that y is less than or equal to 4 in brackets. So that is our range. For example 2, we have a word problem. It says Mrs. Malone buys a paint for $20 per gallon. The function f of x gives the cost of buying x gallons of paint. Write and graph the function described. Determine the domain and range. Tell whether the function is discrete or continuous. Okay, so let's start by writing an equation. F of x is the cost. So f of x is how much she's going to pay. X is the number of gallons of paint. Well, she's paying $20 per gallon. So $20 times x, which is the number of gallons of paint, should tell you how much she's going to pay for the paint. Now let's think about this. When you're buying gallons of paint, you're buying it per gallon. You can't buy 1.15 gallons or 1.37 gallons. So you're going by the whole gallon, which means if you're going by the whole gallon, you can't have all those points in between. So this is going to be a discrete function. It's just going to be a bunch of dots on the graph. Okay? The other thing to think about is our x values. If they're the number of gallons of paint, you can't buy a negative number of gallons of paint. Okay? So you could either buy no paint, which means x is 0, or you could buy more paint. So that means our domain, our x values, is x such that x is equal to 0, 1, 2, and so forth. So it's all those values. Our range then, if we think about it, well, if you buy 0 gallons of paint, you're paying $0, and the price will go up from there by 20s. So f of x such that f of x is equal to 0, 20, 40, and so forth. So let's make an XY table to plot these. We have 0, 1, 2, 3, and 4. So our values are 0, 20, 40, 60, and 80. I know that this XY chart helps students sometimes. Instead of just graphing it in slope-intercept form, you could have also graphed it in slope-intercept form. You would get the same answer because you're going to start at 0, 0. And if you use slope-intercept form, your slope is 20. I'm going to have these lines go by 20s, so I'm going to relabel them. So my rise is 20, my run is 1. The only thing is if you don't make the chart, you just have to keep in mind that when you're doing this, you can't go backwards because then you're going into negative gallons, and that's not possible. Oh, and I drew a line, but should I have drawn a line? If it's discrete, do we have a line? The answer is no, right? If it's discrete, it's just a bunch of points. And these points do continue, so you want to make them continue going on and on. And that is it for this problem. If you have any questions, make sure to contact your teacher.